Hello, everyone. I'm going to be talking about building large language model powered applications with Haystack. I'll tell you about what Haystack is in a bit, but before that, a bit about myself. My name is Tuana. I'm a developer advocate at deepset, and what I advocate for most of my time is Haystack, which is an open source project by deepset. I have a background in computer science, and I've been doing some form of developer advocacy since about 2020, and I've been with deepset for just over a year and a half now, I think, coming up to 2 years. Today, I'm not going to necessarily follow this structure entirely as you see it, but I'm going to start talking about a new way that's at least worth seeing with Haystack of doing search and NLP in general. I'll give you an intro on what Haystack is and what you can do with Haystack. Then this is the main part. The bulk of the presentation is how you can use Haystack to interact with large language models. And then I'm pretty sure some of you, I'm hoping, have heard of this term agents. One of those ways you can interact with LLMs is a pretty neat application called agents. We'll see how you might build your own with Haystack. But that is just one of the applications they might build. I just find it to be the more fun thing to talk about these days. All right, so I'm not going to dwell on this. I did ask what the level of NLP knowledge in this crowd might be. I understand there might be quite a variety. So if you do have any questions, please feel free to ask. But one thing that we definitely noticed is traditionally search applications have been built with extractive models. And in Haystack, we name these breeders. And what these extractive models do, it basically does what it says on the tin. It extracts answers, and to be able to extract an answer, it needs some sort of context to look at. So we always need two things from the user, really. We need a question, but we also need to provide it with a bunch of data for it to actually look through and extract the answer from. This is what that might look like. That screenshot is from a Hugging Face space. It's open. You can scan the QR code to play around with it. It's a very simple Haystack extractive QA pipeline. What we now have, I'm pretty sure you guys have seen this UI quite a bit. It's on ChatGPT. We now tend to prefer using generative components that use generative models. Or now it's kind of weird that we've come to a point where large language model and generative model are kind of synonymous in colloquial language. So if I'm saying LLM, assume I'm saying a generative model, really. And here, what's different is we don't necessarily require any input context input at all. They're not passed to extract answers from any given context. They're passed to generate human-sounding like answers, but also content. It simply can be content. It doesn't necessarily have to be an answer to a question. And this is the same exact question I had in the previous slide. I'm simply asking ChatGPT, which is a very impressive generative model. And it's giving me quite a long-winded answer, but it's correct. And it sounds very much like a human could have written this answer. You can do other things. This is to kind of depict that this is not necessarily just to answer questions. You can ask it to generate content that wasn't there before, give it style even. Here I just said to write a poem about the AI Camp meetup group in the style of a Kermit the Frog song. And that was pretty neat in my opinion. Other things you can do, and I've highlighted this bit because it's going to become kind of important to understand this ability of some generative models to be able to instruct it to do something. Here I haven't asked it to necessarily generate random content. I haven't asked the question. I said, summarize the following text for me, and then I provided it some text. It's really good at doing that sort of stuff, and we're going to see how you might leverage this ability to do cooler things. Here, we start to get into the realm of how the idea of agents came about. Here, this presentation is very similar to one I gave at Python US a few weeks ago. And my idea was I wanted to build a sort of assistant to the attendees of the PyCon events that were held in the US. And here what I've done is I've instructed the large language model saying you have the following tools, and I've made up some tools. Or the idea of tools is even made up. I've said you have a tool called Python Event QA, and I've described how it's useful. I said useful for when you need to answer questions about Python. I've said you've got something called web search, useful for when you need to search the web to answer general questions that the other tools cannot. And then I said, okay, so you have these tools, pick the tool you would use to resolve the following query. And I say, what is Tuana's talk at PyCon? And what is the weather of Salt Lake City going to be like that day? Now, the interesting thing is the response, because in the response, I'm not sure, can you guys see the slides or should I read it out? I feel like there might be a bit of glare. Okay, I'm going to read it out from now on. But the response is to resolve this query, I would use PyCon Event QA to find out when Tuana's talk is scheduled at PyCon, and then I'll use web search to find out the weather forecast for Salt Lake City on that day. Now, this is interesting because now you can see that it's actually come up with a sequence of which tools it should use to resolve the original query. So we're going to see how we can leverage this ability that current large language models have to build our own applications that can actually do this. This last one, you really don't have to read through the whole thing, but the idea here that I wanted to showcase is with this prompt, the only thing I've changed in this instruction is that I've told the language model to explain to me step by step how it would come to this solution and why it would use certain tools. And it was pretty good at doing this. It gave me 4 steps, and at the end of those 4 steps, it's come to the conclusion that it can resolve this query. Now to Haystack. So we've seen kind of with a ChatGPT interface how you might leverage large language models, but it was a very much toy example. We actually didn't use any of those. We didn't use anything called Python Event QA. We didn't use anything called web search. Now I'm going to step back and go back to the basics. So Haystack is, like I said, it's an open source NLP framework. It's built in Python. That QR code hopefully still works, and it was going to take you to the GitHub page that we have. And the idea is that it covers all 4 NLP tasks. So yes, I'm talking about generative QA and using LLMs today, but for an end-to-end NLP application, you tend to need a lot more. There's everything that goes from preparing your files and documents to where you would store your data. Do you want to do a vector optimized database? And then obviously what type of NLP application you actually want to build. Here, the image shows one of the most classic NLP pipelines. The most important thing I would hope that you can understand is the one on the far right. A very classic NLP pipeline, the one we saw at the very beginning, is a retriever component followed by a reader component. A retriever component is simply the component that can look at a large amount of data and extract the most relevant data given the user's query. This is great because then the reader, which is in this case using an extractive QA model, we're going to see how we would use a generative model too, doesn't have to look through all of your documents. If you want to have an NLP application that's working only on your data, this means that the next component only gets to have to go through like the top 5 most relevant documents because that's the retriever's job. And the idea behind Haystack is also that you as a developer get the option, the choices to what kind of model you use, whether that's on Hugging Face, an open source one, whether it's a local one that you've trained for yourself, OpenAI, and so on. And then obviously the next option you have is where do you store your data. So this is the idea of a pipeline. I'm going to come back to this image later. It's one component followed by the next. So it's a very one-path situation. You have everything is predefined, your path is predefined, you ask the query, you get an answer, and your time with that pipeline is done. I will go through this slide because I think everyone gets the idea. The idea is that you get the choice as to what kind of data store you would use and what kind of model you'd use from wherever. And obviously also the next option you have is what kind of components you use. Instead of a reader, I'm going to be looking at how you would use a generator moving forward. The other thing that we try to provide through Haystack is being able to deploy your NLP application. So we have a REST API component within Haystack. So if you do build a pipeline, you're very happy with it and you want external people to use it, you can deploy that via REST API. All right, so now let's have a look at how you might do basically the same thing. So we talked about how a generative model doesn't need context, but for a lot of use cases, and I think there's going to be another talk that does something similar, we don't want it to just generate anything. We want it to, if I'm building something for my company based on company documents, I don't want it to make stuff up. This is where the term hallucination comes up a lot. So we want to basically leverage the Haystack pipeline structure and attach a retriever before the generator. And here we're going to start looking at how you might use large language models to interact with your own data using Haystack. So this is a data set I have on Hugging Face data sets. Like I said, so my idea was I wanted to provide a sort of assistant to the Python attendees. So I simply crawled the website and put everything in there. Everything you see there are talks or tutorials or sponsored talks that there were at Python. So imagine a scenario where this is my private database, and this is all the data that this large language model should actually have access to. There are two main components that allow you to create this generator component in Haystack. One is called a prompt template. The other is called a prompt node. The prompt template is a sort of a flexible way that you can manipulate prompts. It's kind of like a blueprint of how you want to interact with any given large language model. And the nice thing about this is it can be modified at query time, depending on how you build your prompt templates. The next one is the prompt node. This is simply the interface to a large language model. That can be a model that OpenAI is providing. It could be a model that Hugging Face is providing. So we're going to leverage these two. All right, so the first thing is the prompt template. Here, I've created a template called prompt. And what I've done is I've said you will be provided a list of events, reply to the query based on the content of the provided events. And then here is the important part. In blue, you'll see a few things in curly brackets. Those curly brackets are basically telling whenever this prompt template is used, expect these variables, these parameters to be provided by the user. So I'm basically saying something called query is going to be provided and something called documents is going to be provided. Now, what I'm going to do is I'm going to fill in those documents from a retriever who is able to get the query first, look at all the Python event data, decide which ones are relevant. And then already by the time the model has received this instruction from the user or the query from the user, it already has the relevant context, like the extractive QA models might have, already in the first instruction. So where I'm going to end up is something like this. I'm going to read it out for the people at the back. But basically here, everything in blue gets replaced with whatever the query from the user is and whatever the content from the documents that the retriever decided were the most relevant are. This was the rest of it. And so let's try and build something like that with Haystack. First thing I do is I declare a prompt template. Here I called my prompt template, I gave it the name events QA. And basically I told it the prompt text is what I just declared in my prompt. The next thing I do is, and this is the component that interacts with the large language model, is I declare a prompt node and I tell it what model I want to use. In my example, I tested this out with a few models a few weeks ago. Since then, there are actually other models out there. I think there's another open source model on Hugging Face called Falcon 40D Instructs. I did not use that one. I didn't try it, to be honest with you. But back then, GPT-4, I had access to it and it was working pretty neatly. So I decided I'd use GPT-4. Obviously, then you have to provide your API key. And to this prompt node, I basically said the default templates you should use is the one that I just initialized at the top. So this prompt node knows how to interact with this model. I just told it to interact with at this point. So the next thing I'm going to do is I've kind of glossed over the retriever bits. I do have a collab that's, you'll have a QR code in the bits. It's open. You can actually build this whole pipeline from scratch if you want to. I'm basically saying my pipeline, the first component is going to be a retriever. So let's assume you have a retriever. And the input to that is a query. So that query parameter is getting filled by this retriever. And then the next component is going to be the prompt node I just created. And I'm telling that prompt node that whatever the output from the retriever is, that is your input. So that's how the documents are getting filled in. And when I've done this, I basically achieved that image on that graph on the right-hand side. I've got this pipeline ready. And then if I ask you something like, what day is the talk about agents and LLMs? This was a talk I gave at PyCon. I get the answer, the talk about agents and LLMs titled, Swap's presentation, building LLMs, LLM-based agents, yada yada, by Tuana, is on Thursday, April the 20th, 2023. It's the correct date. And it's giving me the time as well. I don't know why the order of the slides have changed, but here is the collab. If you want to build this pipeline, there is one ready in that collab. You simply have to provide an API key or change the model. You might test it out, see if something else works quite well. And oh wait, maybe I'll wait. I saw some people taking photos. And if I ask something else like, I'm interested in NLP, what talks should I see? I was pretty impressed with this result. I actually got a pretty good list, and I got the URLs of each talk there as well. So if you're interested in more context about what the talk is about, you can go to that URL. I will say GPT-4 was great at this. GPT-3 was not, so I was impressed to see how the difference was too. And another example of how you might leverage this type of prompt engineering, let's say, this is very much retrieval augmented generative QA. You're doing generative QA, but you're leveraging the retrieval's ability to get the most relevant content or context before you generate your answer. This is another demo that, again, it's open on Hugging Face Spaces. I called this Should I Follow? And for the retrieval augmented step, I use the Twitter API. The idea was you can enter a Twitter username, and this generates some sort of idea about what that person often tweets about, the tone, and also what kind of language they use. And you can scan that QR code if you want to try it out. I did the one for AI Camp today, and I think it was pretty accurate. This user's been tweeting about upcoming machine learning meetups across the world, etc. All right, so back to this slide. This so far was one way we use or can interact with LLMs with Haystack. It's a pipeline. A node is followed by a node, is followed by a node, and it's going to be a start and an end, and we know it. And the knowledge base is set. This is another important difference. Now we're going to talk about agents. This was my colleague insisted on having this meme here of me. The features of an agent. So an agent is in essence a prompt node, the node that we just saw, but it's a prompt node that's been given a very, very clever initial prompt. So far it was mostly about answer questions based on these documents or summarize X, Y, Z. And here's the important part. Those tools that we sort of made up in the beginning, and we made up some sort of scenario for ChatGPT, it actually has access to these tools. Tools may be Haystack pipelines, other data connectors, it could be even web search. It's up to you. You build your own tool. And the important thing is each tool ideally is useful for one very specific thing, because you have to describe what it's useful for to the large language model. And it creates an action plan to resolve it. But most importantly, when it creates an action plan, it then can invoke those tools and actually execute them. So this is, I've got so many QRs in this presentation. These are the two main papers the implementation of agents are based on. So if you're interested, I highly recommend reading them. One is called React, The other one is spelled MRKL, but it's actually you pronounce it Miracle Systems. These are the two research papers that the implementation of agents in Haystack is mainly based on. So again, back to this slide at the beginning. This, I'm pretty sure people at the back cannot see this, but long story short, this is the instruction we gave at the beginning and asked the large language model to come up with an action plan, step by step, explain to us which tool it would use and why. So we're going to achieve that in some shape or form. Again, as with all the others, it's really based on the initial instruction and how good it is. And the initial instruction by default in Haystack that we provide an agent is called zero-shot react. And the most important thing that you should notice here that at the top, there's another thing in blue in curly brackets, and that is tools with names. And there's going to be a function that you're going to see for an agent called add tool. And that is going to dynamically add to this tool names with descriptions parameter. And then finally, it's going to have the query by the user. Now, this is where the agent is different to the pipeline, where we saw that how it was one path and it was node after node after node. An agent, in my mind, I kind of see it as like this entity that's always there. And it always has access to these tools. And the path is kind of defined by the agent. At each step, an agent decides, have I reached the final answer? In which case, we're done. That's where life ends with the agent. But if it decides it hasn't, then it can dynamically choose, oh, I'm going to use this generative QA pipeline you just built, which is a one-pass pipeline. And then based on that answer, it might say, okay, I'm not there yet, and use something else. That's where it's quite different to how a pipeline operates in Haystack. And yes, this is if you sort of zoom into how an agent operates. This is kind of how I visualize it. You get a user query, and then the agent says, have I got the final answer? At the first pass, it's probably going to say, no, I don't have the final answer. It's going to think about how it can formulate a query for a tool that it's about to pick. It picks the tool and observes the result from that tool. Observes the result from an extracted QA pipeline or a generative QA pipeline. And then if the observation, it decides, great, I have the final answer, we're done. If the observation, it decides I do not have the final answer, it will do the loop over again, where it decides which tool to pick at each situation. So I did my PyCon assistant slightly differently. I changed the initial prompt just a bit to help it out. My zero-shot react prompt wasn't working great, so the original prompt I had to modify a bit. I'm just giving it a helping hand, saying you're an agent for PyCon events, to make it understand that it's about or should expect something about events of PyCon. At the end of the day, I'm going to build an agent that basically fills it in with these tools. I'm going to actually give it a PyCon events QA tool. I'm going to tell it's useful for when you need to answer questions about PyCon events. I'm going to give it a speaker search tool. And there's a reason for that, because I found out that one of the pipelines I built was using embedding retrieval. It was not great at speaker names, obviously. For speaker names, I decided I'd do another pipeline with keyword retrieval. It wasn't great at say, like, a question like, when's Tuana's talk? It wasn't able to, extract the relevant documents for Tuana until I switched to a retriever that was doing something keyword-based. And then I also added web search as like sort of my fallback. If there's a question that's PyCon event-based is not going to be able to answer, then use this one. So let's build that. So the first thing I do, like I said, an agent is like in essence a prompt memory. So I tell it that I'm going to be using GPT-4, and I give it my templates, the prompt template that I just created. And then I create a tool. I give it the generative pipeline we created just before as my PyCon events QA. And then I add that tool, .add tool, and now the agent has access to that tool. The next thing I do is speaker search. Imagine we created a pipeline with keyword-based retrieval here, and I simply add that tool, and now the agent has, at all times, access to two tools. And then finally, I'm going to do something called Web QA pipeline. This is another pipeline that's available in Haystack. Here we use Server Dev. it requires another API key. And I could create a tool and I tell it's useful for when you get a question that can't be answered from a knowledge base and Python event data. And then I add that. Now my agent has access to 3 tools. Now when I say, when is fun talk with Python and what will the weather in Salt Lake City be like that day, which was the original question we used as a toy example with ChatGPT, I end up with a thing where I can actually run it. I'm going to end up having to read this out because I think the screen is maybe too dark and far away for you guys at the back. But it's a video of my agent actually running. And first it picked speaker search because it realized that Tuana is the name of a speaker. So it did keyword retrieval for my event. And then it did web search. So it retrieved my event data, saw the dates. Now it knows it has to find the weather at Salt Lake City for that date. And then it did web search for the weather on that day. And unfortunately, it was terrible weather that day in Salt Lake City, but it did get the right results. And that is the second way you might leverage large language models or use large language models with Haystack. So, yeah, there you go. These are the 2 QR codes there. One of them is the most simple tutorial we have on agents. It simply does multi-hop QA. The other is a webinar we held on prompting and best practices for prompting. And yeah, we have a Discord server. If anyone does use Haystack and needs help, please do join. We're always there. I'm happy to help. Thank you. Can I take questions or should we move straight to the next one? Yeah, go for it. Yeah.
When you talked about the agent and the tool that manages to find the correct answer, how does it evaluate the answer?
That is the problem with agents right now. If it doesn't get the right answer when it executes the first tool, if it doesn't get the right answer, it might still decide that's observation is the input to the next tool.
Like, is there some sort of score that it uses?
You can. So one thing that we have been sort of experimenting with is called a node called the entailment checker. But that means you have to add it to your pipeline to begin with, and then use that score. So the output of the tool is basically your design of the pipeline at the end of the day. So if I want to do something like that, I would have a pipeline and make sure that pipeline's result in some way is informing the agent of the accurateness. And the entailment checker is this custom node one of our community members built, which looks at an answer or something, a claim, and then it has like access to a set of, what we would imagine as like ground truth data sets, and tells you whether the claim is entailed in that data set. Possible. I have not tried it myself for an agent. Yes, that's it.
What are pros and cons against like competitors like LangChain and all of this?
I think the agent implementation of LangChain and Haystack are pretty similar. This is one thing that we provide with Haystack. I've just talked about agents because I like talking about LLMs these days. That's the idea behind Haystack right now. The really core thing we're trying to provide is the whole end-to-end aspect of an NLP application. So with Haystack, you'll have file conversion and indexing and REST API, etc. already. But that's evaluating beyond agents at this point.
Yeah, I think I had a similar question. Basically, when we implement any of these APIs, for like large models, ChatGPT or whatever, we can design it how we want to. So when implementing a library that implements these for us, we usually are like, well, what is this offering us that we couldn't implement ourselves, because we also don't want to be restricted by not being able to have our own implementation. So I'm wondering what you'd say is the biggest thing you offer, and also do you offer enough customization for a user to be able to implement like their own functionalities inside of it?
I think probably a customization is the thing we offer at this point. So the idea behind this and us going ahead and implementing our own agent implementation is we started before this already had document search and customizing document search for your use case ready. extractive QA, generative QA, etc. The idea is an agent is something we want to provide our users to be able to use those various different data resources they might have for different pipelines in an agent application. So I think that is probably the core thing we offer now, very much customizable. And that, for example, that entailment checker, every component in Haystack or pipeline node, let's say in Haystack, is you can build your own, it's customizable, it's based on the base component. And that entailment checker is not built by us. This community member needed that sort of implementation and went ahead and built entailment checker as a Haystack node.
Let's move on to the next speaker.
It is really hot here. So
Yes. People wanting to move forward to more seats here to see it better.
Figure out if I can make the phone for the stage. Wi-Fi or NPM for like aging tools.
I don't know if he's here. I'm still fine. Yeah, but it is pin, but I don't know how it works.
This is M15.
And that I can only pin. And this is already pinned. I was looking at it already.
So long time ago.
Right?
Work with Haystack. It's That's all.
yeah, so there's no structured guideline.
I've been here before.
All right, time for the next talk by Elina. Say grabbing drinks. Yeah, so Elina is going to talk about her chatbot she made for Creative Fabrica using GPT. So,
Thank you. Hello, everybody. My name is Elina Oikonomou, and I'm a product owner at Creative Fabrica. Indeed, my talk is a really nice continuation from Tuana's talk because we're going to see how we can actually build a real-life application to automate customer support using LLMs and GPT-4 and ChatGPT, and actually how to perform in real life and in production. All right, so what I will be talking about, I will start by setting up the scene. So I will talk about Creative Fabrica and what we do and actually why we were at the point where automation was needed. And then I will talk about how we built our chatbot using LLMs and our own knowledge base, and then how we built a complete product out of it from the user perspective and also for admins and agents. And then at the end, we'll see the results, how it performs in production, and what's next. All right. Who of you have heard about Creative Fabrica before? All right. That's nice to see. I mean, we're based in Amsterdam, so we're in the city here. So our mission is to enable people who are all about creativity and they're into crafts and they want to access like different assets, different tools, different fonts. And we're there to support them throughout their whole creative journey, from inspiration to tools to education to support. We're a new startup / scale-up. It was founded in 2016. And maybe you have heard about us on the news the last end of last year, because we raised our Series B. And also since last year, we started launching our new family of tools under the umbrella Celik Spark, which are all about generative AI and generating assets and images using those tools. Where are we today? We have over 250,000 subscribers and 4 million registered users. So we're really in the scale phase, and we're having intense growth and intense increase of users. So a bit of our platform, as I said, we try to be there at the journey of the creative people from the beginning. We inspire them, then educate them, then help them create the tools, give them access to all the assets they need, and also platforms where they can share the creations, communicate with each other. Yeah. And of course, what we have seen since last year is that the creative process has changed, especially now with generative AI. More and more people have access to these really powerful tools to generate on their own these like creative assets. That's why we launched Spark, which is really a family of tools based on actually different models with generative AI to create all these assets. And we give them to users to basically enable them in their creative journey. Okay, now let's talk about customer support, which is more my domain today. So why there was a need to automate, and there we see one challenge there, and it's about scale. So we have an internal customer support team in-house, and 2 years ago we started with 5 agents, and we're like way small, so we had 1 million users and way less products. Now we have grown to 4 million users, and the team has grown like 3 times. And now, since we're like really growing in the number of subscribers and tickets, we see that if we want to, for instance, service 2 times the amount of tickets, we need 2 times the amount of agents, which very quickly becomes very unsustainable. And also, yeah, we want to go to more product categories or include multiple languages, it quickly gets out of hand. And that was a challenge that we noticed end of last year, where we're sitting with a nice backlog of more than 1,000 tickets waiting for us to answer, and we're getting back to consumers like with a 1-week delay, and it was becoming quite a problem. But now, like, why customer support and excellent customer support matters for us? It's because actually 86% of users that they're likely to stay with the brand and make a next purchase if they receive excellent customer support. And also 77% of people who got excellent customer support, they're likely to recommend the brand. So it's very important for the business. And also poor customer support is the leading driver for customer churn. So people who receive, have a bad experience, they're very likely to leave the brand and never use it again. And the main driver there is incompetent and rude staff and very slow service. All right, so the solution is, let's build a chatbot. So how it started, very simple. ChatGPT was launched, so we're like, okay, let's build the chatbot. What enabled that? Obviously, the really friendly conversational interface and the really fast user adoption. It was a great sign that we can use this technology and it's mature enough to build an end product for it. And the brief was very clear. It was like focus on impact, meaning automate as many tickets as possible without human interaction. So that was like our focus since the beginning. So when starting with it, we looked at, okay, what data do we have? Because like people who we come like from machine learning, we're like, okay, we have historical data, maybe we can train a model, things like that. And we had lots of data at Creative Fabrica. We had a lot of help desk articles, and 200,000 historical tickets and internal knowledge documents, etc. However, we quickly realized that it might not be very sustainable to use them, or we have like quite a few challenges there. First of all, the data quality was a big one. For instance, we have historical tickets, but we don't know if all of them were good replies from the agents, or if the information is up to date, because we have tickets from 2 years ago, maybe the information is not useful anymore. Or most of the data were unlabeled, and even when we could find like some tags on topics or intents, etc., there was a very big misalignment in the way that the agents were tagging the different requests. And then, of course, the labels that we had, they were more on conversation level, but then we wanted to go deep into message level. That was like a very big challenge. All right, I borrowed this really nice graph from a blog post from ML6 to explain, like our approach. So, the question that we had in the beginning was, okay, do we use all this data that we have to train a model? And that's basically the classical approach. So we start with a pre-trained model that is trained in a very large knowledge base and like public data. And then we have our own domain-specific knowledge base. And then we fine-tune the model, and then we get a new model that has all the generic knowledge, but also knowledge of our own specific use case. And then if we want to, we query the model, basically we ask it our question, and it's supposed to know the answer. So that's the classical approach. However, there are a few challenges with this. First of all, when we get a reply, we cannot pinpoint what was the source of this reply and whether it belongs to our knowledge base or from the generic knowledge base. We cannot have fine-grained control of who has access to what information. Also, if we have new information, for instance, we launch new products or new services, then we need to retrain again the model to have this new information. And then, of course, we have to have all the infrastructure of hosting a model, train a model, etc., which adds lots of complexity. So what's the new approach? I think nothing new here. It was also discussed in the previous talk. So we go to the retrieval augmented generation. So basically, we ask a question, and then basically have our internal knowledge base, and we have a smart retriever that basically matches the question from the user with the most relevant documents that we have sitting in the knowledge base. And then basically we prompt a large language model, which is the generator, with the question and also the context. And then the generator provides a reply to the user. So that's the high-level concept now of how we build our chatbots. All right, so then how we built our knowledge base. We split it in two parts. So we have the topics, which is the general categories of the frequently asked questions that the users ask. And in this case, we have like questions about subscriptions or copyright or account. So the generic topics. And how we used the topics. Basically, when we receive a question from the user, we do a topic classification. And then based on that, we can have some control over whether we want to reply to this question or not. Because, for instance, we specified that, okay, our chatbot, we want it to reply to questions about account and subscriptions and licenses, but we don't want it to reply on topics about refunds or copyrights. So we use this to either give a reply based on our knowledge base or prompt the bot to say, oh, sorry, we cannot reply, please ask support. Also, we have some other settings to help like the user experience. So for the bot replies, we also ask for feedback in the form of thumbs up or down. So whether the user liked the reply that we gave to them, and also we have functionality to activate or deactivate a topic, because maybe again we want to launch something in the future and we want to start building the knowledge base, but we don't want it to be activated. And then we have the FAQs, that is basically the knowledge base of pairs of questions and answers. And this is the ground truth of the replies that the bot generates. So the user question is matched to the most similar FAQs. And then these FAQs are given to the context, to the generator, and based on that a reply is generated. And then we see that, of course, the quality of the chatbot and of the experience is directly linked to the quality of the knowledge base. Okay, I'll take one question now.
Might be a dumb question, but so you match to a certain FAQ entry. Just replying with that FAQ entry, is that much worse than doing the extra step of going through a generative model?
Sorry, can you?
Give an FAQ and
Yeah.
that you find that's probably relevant, and then you use that as a context for your generative model. How much does it actually add to the quality of the reply versus just showing the FAQ entry that you found?
Yeah, the difference is that basically you can have this conversational experience, right? So the generator, we use GPT-4, and it really has a conversation with the user. So it can do like follow-up questions or not just provide the raw information, but do it in a nice, friendly way. So it's really on the experience. Yeah, I would say that's a good piece.
Do you learn from the interaction? So you have a conversation, and then can you make better answers or better content or whatever?
Yeah, I will answer that. I mean, I have a presentation, so we'll see if we yeah. Okay. Then another thing that we did and we found really nice in the end user experience was to personalize our chatbots. So we didn't want a very mechanical one because we work with creative people and people who are doing that in their free time and they're passionate about it. So we wanted a chatbot which is like very friendly and make jokes. So actually we defined a persona for it. And we called it Genie, and it's a Creative Fabrica customer support bot. And we said to Genie that it's a female, but it's subtle about it. And then that it's friendly and funny and makes witty jokes whenever possible. And also we said that, okay, also reply with the pink Genie emoji because they're not, to give like the personalization element on the chatbot. So this is how it all comes together in the flow. So first the user sends a message and then we create or we update the conversation because we keep track of all the conversation between the user messages and the bot messages. Then if it's like a follow-up question, we have a step that they construct the intermediate question creation. And that's very useful for follow-up questions because it rewrites the user question with more context if needed. For example, if the user asks, okay, what are the subscriptions that you offer? And then the second question is, which one is the best? This doesn't have a lot of context, so it won't match really nicely with our knowledge base. But in this step, the question will be rewritten as which subscription is the best. So it will have like the context. And with that, we do sentiment analysis. So we classify the message from very positive to very negative. And also we do the topic classification. And then we do also the topic analysis. So whether a specific topic that we identified, we want the bot to reply or not. And based on that, we construct the prompt. So we use the information from the bot persona. So we say, you are Jimmy, the customer support bot, and you're funny and make witty jokes. And then we have the reply style. So now, okay, we're on the chat widget. So you're make a conversation on the chat. So keep the replies short and to the point. And then we say, okay, this is the context. And this is the user question. Please provide the reply. And then the model drafts a response and sends it to the user. So that's like the main structure of the chatbot. So then let's discuss about, okay, how we build a product basically and an experience out of it. And to give it to the users. So what, we named the product the Genie, from Genie. So what were the two main components that we built? The first is the chat widget, which is basically a support button that we place on the main platform of Creative Fabrica. and it's always there. So when users want to ask a question, they just click on it, and it's like a chat widget where they can interact with the bot and ask the questions. And also we integrated with our current customer support tool that we use. So in case the chatbot cannot answer the question, users can very easily still open a ticket and follow the existing flow, in order to get the support they need from an agent. And then we built the back office app, and this is for administrators and for agents, where basically we can review all the conversations that the users make with the chatbot. It's also where the knowledge base sits, so the topics and the FAQs. It's also where we can personalize the chatbot and customize the widget, etc. And also where we can evaluate the conversations, analyze them, give feedback in order to go further. That I will explain later. This is the interface, the chat widget. We try to keep it as like simple as possible, so to really simulate how we have our chat interfaces like WhatsApp or Messenger. Basically, not to look like the more traditional chatbots, so they have like different options or buttons, etc. We want to move away from that and have like a really clean interface. Still, the contact support button is always there after the first reply of the bot. So we want the user to send one message to interact with the bot, and as soon as the first reply is returned, then the contact support button is always there. Then we ask feedback from users on the bot replies with thumbs up or down next to the bot messages. And also to drive more personalization of the chatbot, we have generated some fixed messages that they're very aligned with the bot persona, such as the welcome messages. And then if users click thumbs up, there are messages that are like, oh, I'm super happy, you like the reply. Or if it's negative, to say, oh, I'm sorry, let me know how I can help you further. To drive personalization and engagement with the user. All right. So what's the user interaction flow now from a user perspective? So the user sends the question, and then on the background with the dot classification, the sentiment analysis, and we generate the reply. And then if the bot can generate the reply, it just continues the conversation indefinitely. And if not, then the bot will give a reply that says, oh, sorry, I can't answer, please open a ticket. And when we open tickets, basically we also send the tags there. So we tag with the conversation, with the message topics that we identified. We also tag the priority. So if we identified negative or very negative sentiment, we send the ticket with high priority. So our team knows to prioritize those requests. And we also send the conversation history. So our agents have context of what has been discussed before.
About the topics that Genie cannot answer, how do you determine that?
So we have identified it in our knowledge base, and it's like a setting. So in our database, we say, okay, have the topic account, and then it's do I want to reply or not? And then we have the back office app, which is basically a workspace for the admins and the agents, where we can specify the bot persona, we can customize the widget, adapt it to the colors of our brand, or change the icon of the bot, or connect it to, if people use this customer support tool, connect it to their tool to be able to create tickets. Also, we have the knowledge base with the topics and the FAQs. We have a conversation overview, and there the agents can actually evaluate the bot replies. And Actually, maybe I can do a demo at this point. Maybe I can show you how it looks. Okay, I think that's better. It's talking. Also, these are really nice mockups for the front end that we are building. Our current back office app, we have built it in Django, and it looks a little bit more rough, but it works really well. So maybe I can show you how it looks and what it does exactly.
Personalize them.
All right. By the way, this is the second version. We were live with our proof of concept till today, and we put that live today, this afternoon. So I think it's still working. So I'm very happy about that. Okay, so yeah, I'll start with when you set up the first bot, right? So we set up the bot persona first, and now it's Genie, and we have select here the name, description, the gender. You can put also not defined if you want. Then the personality traits. We do our use case, we discuss and support. And also we selected which languages. Actually, this is linked to the widget, not as much as the languages that the bot replies, because the GPT-4 out of the box replies to any languages, and that's a really cool benefit actually, because our knowledge base is only in English, but then the chatbot replies to any language that the user might ask it questions. And here the emoji. Here it's where we customize the widget. So, and that's like a demo. So we have like the color and which chatbot icon we want to have, and how the icon we want it to be, like whether big or small, and whether we want to have like an expandable here icon, and we link it to our Zendesk account. And here's the code snippet that basically we take and we attach on our platform, and then it's live. And here, basically, the overview of the conversations. So we can see which conversations are like in progress right now, and here more historical conversations. And you can see their status. This is the priority. So if the sentiment identified was negative or very negative, we flag it as a priority. This is the user feedback and agent feedback. This is whether it was automatically closed, meaning that if it's automatically closed, it means that no ticket was opened afterwards. And if it X, it means that the user in the end opened a ticket, and it went on our customer support tool. And all right, let's go on the one. So what we can do here, basically we want the agents to go and actually evaluate a few conversations to monitor quality and also improve over our knowledge base. And how we do that, here they give feedback, and if it's like a good reply, they just say positive. If it's a bad reply, they say negative, and then here they write in the feedback how a correct reply would look like. So I'll make here. So this is a correct reply. Correct. And also something else which is useful, we can also see which FAQs were used as context to generate the response. So we can directly track, what kind of information was used for this. And then we evaluate the conversation, 5 out of 5. And we submit evaluation. All right. And then what we do with that is when our admins, the manager of customer support, go through all the feedback here, where we collect this, we collect the user message, the bot message, and the correct reply from the users. And we can either change here the FAQs, or we can just create the FAQ and basically add it in our knowledge base. So then immediately, and the next user asks a question, the bot immediately can reply to it. Yeah, that's the main thing. And then we have the dashboard where we can get analytics on the activity, and then more detailed information about how the topics perform, what topics people were asking, and what's the automation rate for each topic, etc. And from feedback that we got from the team, that's very useful for to steer the team basically on a higher level. All right, and then we say, great, congratulations. How did it work actually? Okay, so we put Genie live end of March. So she has been there for more than 2 months, interacting with the Creative Fabrica users. And in general, the feedback so far has been like very positive. Users like it in general because, first of all, they can get instant replies to easy questions, so they don't have to wait a week to see how they can activate their account, which is great. And also they, I think they like the experience in the interaction. For instance, there are like so many conversations that people have like lengthy chats, and they just talk with the bots and they ask follow-up questions. Or I think by now people maybe know that it's GPT-4, so they start playing with it, which is nice to see as well. Or it's fun because they might ask this to generate good prompts to use for CFR to generate images. So it's like a full circle. Also, the team actually received the tool very positively. So they saw, at the beginning, they were a little bit more hesitant, what is this, what's going to do? But in the end, they saw like the impact that it really takes away the load, especially of the very easy and repetitive questions. So they can focus more on questions that the contribution matters the most. And the company as well, we're very happy with the performance because we have like full control of the knowledge base, and Genie is now a brand ambassador, let's say. And can also monitor the performance and improve the knowledge base or help the team to improve on some topics or from the top level. All right, and what are the actual results? So it was nice to see that it was working quite well from day one, and we are more than 2 months now, and on average we do 10,000 conversations per month, and out of those, around 71% are automatically closed, meaning that no ticket is opened afterwards. And the feedback from the customers with a thumbs up or down on the bot replies, it's 86%. And the feedback from the agents that evaluate the replies, whether it's they're correct or complete, etc., it's 91%, which is actually comparable to the evaluation of our own human agents, because we also do training for our in-house agents. And 71% automation rate means that it's around 7,000 tickets deflected. And when we started to build this, we calculated the actual cost to reply to 1 ticket with our team. And that cost was 5.5 euro per ticket. So we estimate a rough saving of 38.5K, which is it makes a good business case, say. So now what's next for us? We want to unlock new channels. So I think integration is very important here. So we're building our email support because still most of the requests that we get are through email and not as much as the widget. So we want to build, we're building a service that basically we want to do the first filter of this. And in case, again, a request it can be answered from the knowledge base to generate a response and send it via email. And then if not, and if an action is required, Yeah, we have like a different flow to make the process more efficient for the agent that they have to take the action. So what topics are interesting for us right now? We're looking into. Yeah, we're looking into intent classification to really identify whether a question from the user is like it can be answered only from information from the knowledge base or an action is required. And then, yeah, we're going to start looking into personal identification information and mask them because it's more often on emails that the users might send some personal information. But of course, we cannot just send to OpenAI like that. We have to hide it first. And then the second thing that we're working on is a Slack bot. So the concept is very similar in terms of the experience and flow with the chat widget, but this unlocks a completely different use case, which is for internal use. So then we can have a knowledge base which is for HR or internal policies, and then it's for the employees of the company. So same flow, but different use case. All right. So this is what I wanted to share with you. Yeah, questions?
Yeah, I was wondering, so whenever you're deciding which FAQs to use to prompt with, you also use an AI to like determine which FAQs to choose?
Actually, I think we have our database, and then we create the embedding of, we work with embeddings, right? So all the FAQs have the embeddings, and then the question is also embedded, and then we match based on similarity the user question with the most relevant FAQs.
So if they're replying, sorry, go ahead.
No, I was just curious about the database.
Yeah.
Good question. I can follow up with you later. Sorry, I don't remember by heart.
Yeah, I would just, because like it takes questions in any language, like you may not support everything. So I'm just wondering if maybe you did add an AI layer there and then provided it with like maybe all the keys to all your FAQs or something that you could like have it decide which ones would be the best ones to like build its own next step out of it.
Yeah, so this about the questions actually does it automatically, so you can match a question which is in whatever language to the FAQs that they're all in English. So it doesn't really have a problem with that.
Okay.
So you use an LLM to make a generation answer, right? Which one?
So we use GPT-4,
Yeah.
and for all the rest intermediate steps, we use ChatGPT.
Yeah. Okay. And so could that lead to privacy concerns because you are passing on to GPT-4, perhaps on saying, "Hi, I'm Felix, and I have a big problem because the trousers are too small because I've gone so fat."
Okay. Yeah. So we noticed that in general on the chat widget, because of the format, people don't share a lot of they don't share actually private information.
Yeah.
Also, we have an agreement with OpenAI that first of all they store data for a max of 30 days, and also this data and then they delete it. And also this data is never used for training or for other reasons. Indeed, this becomes more a concern when we want to incorporate email, but we're going to have a filtering step before we send the data to OpenAI.
One more question, and then we can maybe continue. The experiments with prompt injection, and is that an area of concern?
With prompt
Injection, like
yeah. So if users try to prompt, yeah, actually they did try, but I have to say that GPT-4 is the security features are very good because it never gives an inappropriate response, or it actually can handle it very well. But there were people who were trying really hard. That's true. Okay.
I'm gonna open a window here. Hopefully, everyone can maybe get a drink or order less. So it's very hot. Yeah, fun. Yeah, being nice, that helps. Just that.
Yeah, sure.
Why would it? All right. She'll be here. Like some circulation. Yeah, that's okay.
Developer.
Okay. For now, we develop, right?
It's like, yeah, it's like a song. That's yeah. There's. That should be fine. I think they're. I can talk about. So it's something that's something unnecessary. It's for me. I am the nice. Well done. Yeah.
Oh my God.
It's on everywhere, but especially that corner. It's well. Here's the question.
I feel I see missing because of what? The wall feeling.
Something almost there.
It's the door. Yourself is. Also,
I see nog luider. Yeah. All right. Shall we continue? Is the volume also good now in the back? It's the loudest we can get. Is everyone ready?
Also, I was about to ask where your protagonist.
There you go.
So now, so you're for your Christian, that's a different. Or
Yeah.
That's a very interesting.
Yeah, exactly. Yeah.
And then we have.
Is everyone ready to get started for the last presentation?
And now, yeah, and now so decide the advance the particular information they have. But they do is on now we
All right. Time for the last stop.
guys, they're on the conversation. Yes, I did. Yeah, and the information that influence chip back for your data.
Yeah, like we also store conversations.
Agreement to bestaan met vrij. Ik bedoel, AWS is ook inderdaad.
It's something to do like we send them GitLab.
Ja, OpenAI wel van de.
Right, you got them.
After passing websites.
Oh, you get that.
Ja, ik weet dat vooral hoe waar is het wordt. Kan je research
A lot myself.
Yeah.
But I did this before a lot.
Yeah.
But it's more
price.
I'm not to worry about.
Laatst
I'm-
Go on, but yes, so. All right, time for the last talk by my colleague Karel, who will explain the basics of diffusion models and show some of the famous examples. So, good luck. Yeah, hello. Everyone back can hear me? Good, too loud, not too loud, okay. Okay, first up, I'm gonna make some advertisement for another meetup. So if you're here, you're probably interested in NLP and machine learning. So we actually have another meetup coming up, the 27th of June. It's also here. And it's actually someone from Hugging Face and a colleague of ML6 who's gonna speak, Niels Roge. So will be very interesting. So please join. All right. With that out of the way, I'm gonna give you an introduction to diffusion models. So it's something completely different from the other two talks, or maybe not completely different, because actually Fabrica, they make images using diffusion models. Maybe who am I? I'm Karel. I work at ML6. I have worked at ML6 for 2 years. I'm a machine learning engineer and a big diffusion model enthusiast, which is why I did some research on it and I'm giving this talk. All right, so let's start off with the agenda. So first, maybe you have heard of diffusion models already, DALL-E, Stable Diffusion, Midjourney, things like that. So what does this all mean? What are these models? So that's what we're first going to sort out. Then we're going to take a short journey to 2-pixel world. Then we're going to see where math meets poetry, namely in prompt engineering. And finally, you're going to roll up your sleeves and do some prompt engineering yourselves. So get ready for that. So first up, what are diffusion models? It's a pretty hard question to tackle. So maybe it's easier to start with why are diffusion models? So what do we actually want to do with them? What's the goal? The goal you have with diffusion models is fairly straightforward. Is we start off from a piece of text. For example, an analog photograph of a dog wearing a party hat for the people in the back. We put it in some magical math box and out comes a picture of the thing we described. This is what we really want to get. Why? Because it's very cool. So we have made a few attempts for this. Some were, for example, generative adversarial networks, which you may have heard of or GANs. And we also have variational autoencoders, which were less famous, but also pretty cool. And now we have diffusion models. The problem is that to explain this, we would need a lot of math, and it's quite hard. So we're going to make it slightly simpler. We're going to leave out the text for now. We're just going to take our magical math box, and it can only generate one thing, namely, in this case, a cat. So this is a machine that only generates brand new cat images. This is still pretty hard to explain. And why is it hard? Maybe for the people that don't work with image data all day. Actually, for a computer, an image like this one, with a lot of color in it, actually consists of red, green, and blue values, as you all know. And those red, green, and blue values are actually just numbers. So they're just matrices of numbers, usually between 0 and 255. So the larger the images, the more numbers we have, the more dimensions we have, the more complex things become to explain. So what can we do? We can reduce the number of numbers we have, namely by going to 2-pixel world. So in this world, there are some rules. Images are made of 2 grayscale pixels. So grayscale means only a value between 0 and 255. And they're only cats. Cats look like this. It's important. There's going to be questions later. So light, dark. And there are also UFOs. And UFOs look like this. Dark, light. Okay. Ready for a quiz? So first we start off with this 2-pixel. And what is important, we're going to think of these pixel values not just as colors, but also as coordinates. So actually this grid of coordinates represents all possible images in space. So here we have a variation from 0, 0 to 255, 0, 0, 0, 0, 255. So all possible images of 2-pixel world are on this grid. All right, so with that said, where would a 2-pixel cat fall on this grid? Top left, so that would be, this is black, white. So any other guesses?
Bottom right.
Bottom right, very good. Indeed, our cat falls there in the 2-pixel space. Then, 2-pixel UFO, where would that go? Already heard it before, previous question. You can just point. No, it's fine. Okay, yeah, that's better. Great. Okay, yeah, indeed, it goes there. All right. Next up, this one without labels. So what's this? This is light, dark. Where would this go? Just with the hands again. Let's see. Yeah, I see some hands. All right, indeed, goes there. And this one. Indeed. Okay, maybe a tougher one. I don't know if it's tougher. Yep. All right. So if we keep doing this, and we keep putting all these samples of cat and UFO images on this square, we actually start to see some sort of pattern. So we see that all the UFOs, they fall somewhere over here, and all the cats, they fall somewhere over there. Actually, we see that it kind of follows a distribution. Like it follows this heat map, basically. And we can draw the heat map. And once we find this distribution, so let's say we can make a model of that distribution, we actually solved our problem. We can just take a new point from this distribution. For example, like this. We know like this is a cat distribution. We take a point from that distribution and ta-da, we have a brand new cat photo. So this actually solves our first problem, but only in 2-pixel world. And of course, we want to make real images. So to scale it up, and then the real world has some annoying complexities, namely that for every pixel we actually add an extra dimension. So that looks a bit like this. So let's say we have 2 values as before. That gives us a distribution like this. 3 values becomes a bit harder in 3 dimensions. 4 values, no way to represent 4D space. We can't do that. So let's do some quick math. Oh, let's see what the thing is there. So for like a very tiny image of 64 by 64 pixels, that would actually give us 12,300 dimensions. So that's like a very complex space. But the important point of that space is that there still is a cat image distribution. It still exists. It is just really hard to visualize and to model. But maybe there are ways to approximate it. Maybe we have found ways to approximate very complex distributions, and we have, of course, and that's where diffusion models come in. So the diffusion models, that's actually the only thing they are. They're really good approximators of probability distributions. And we stole them from thermodynamics, so that's like real science. So they're good. They're trustworthy. All right. Then how do they really operate these diffusion models? Well, actually, they're just denoisers. So a denoiser is a model that takes an image and makes it a little bit more sharp, a little bit more clear, takes away the noise from the image, but they're denoisers on steroids. What they do is they start from an image that is only noise, and it keeps removing noise until we arrive at an image that it was trained on, for example, the cat. So what does that look like? So we start from complete noise, and it diffuses into a cat image. Then how does the training look like for a model like that? Actually, what we do is we start off with an image of, for example, a cat. So this is an image we give it to the model. We add noise to it ourselves. We add more noise to it. Even more noise until all information is destroyed from the image. So this is not a cat anymore. And what we then ask the model to do is to learn how to reverse the noising step. So we ask it, okay, this is noise we have. Can you take it one slight step back? And another tiny step, and another tiny step. So the model just learns to denoise. I'm going to take questions at the end. So that's what the model learns. And then to create a brand new image, we just give it a different random noise, and the model has learned how to take away noise to finally arrive at a brand new cat image. So how can we, then that actually gives us the goal we had at the start. Now we have a model that can just generate brand new cat images, which is nice. Actually, to conceptually go back to that probability distribution, what we're actually doing is the noise, let's say that it's 3D space, it's not, but the first noise image is just a random point in the space. Then the next denoising step is actually we push the image a little bit closer to the cat distribution. The next denoising step even a little bit closer, and then the final denoising step ends up somewhere in the distribution. So the denoising really pushes our image closer to the great cat distribution. Of course, we now have our model that can generate cat images, but it has a very big limitation. It can only generate cat images, so we're not there yet. We actually want to be able to generate whatever we want in any configuration we want. So now we would need to train one model per thing we want to generate, which is a bit inconvenient. And but yeah, there's no real way to change that, or there wasn't a real way to change that until 1.5 years ago. We can't talk to the model, so we can't tell it what it's seeing, how to interpret what it's seeing. So the only approach we have is to only give it cat images so that it will generate those. And this is actually a technology that has existed for about 15 years, I think, so it's not very new, diffusion models. Models like this have existed for, yeah, I think they've been published in the past 10 years already for human faces, stuff like that. So what changed is actually OpenAI. Before they were famous from ChatGPT, they already released something else called CLIP. And CLIP is a model or is a technique which stands for contrastive language image pre-training. And mostly the contrastive part is important. And you can see CLIP as something that translates between images and text. So whenever you hear CLIP, you just think, that's our translator between images and text information. So it can do both. It knows text, it knows image. And how it, skip that. All right, so actually what it was developed for initially was zero-shot classification. So for example, we start out with this image. We give the model 2 labels that we pick ourselves, just random. It's just random text. For example, we ask it, how close is this to a robot and how close is this to a cat? And the model by itself, just by being trained, gives us an answer of it's 100% close to a robot, 0% close to a cat. But when we give it 2 different labels, a robot or a painter, it's a bit more confusing. We can see that it understands the image. It knows that it's both a robot and a painter. So the model really understands text in a conceptual way. All right, and how did it learn that? It learned it by, so here we have text of, we have 2 samples, for example, a UFO in text form, a UFO in image form, a cat and a cat in image form. What we do is we translate it to something mathematical, to something we call an embedding. So this is a text embedding, this is the image embedding, text embedding, image embedding. And what we want is for the text embeddings and the image embeddings to be close together. And how we achieve that is actually by iteratively just pushing the image and text embeddings that correspond closer together, like that, and pushing the ones that don't correspond further apart. And if we do that, it's a very simple process. We're just like electrons and protons that just repel and attract each other. We see that the things that represent the same concept, they will end up in the same place in the mathematical space. It's very complex, but just remember, it pushes things apart, pulls things closer together. And what we now have is a model that can understand both text and images. And we can use it in our training in the following way. So before we had the problem that we couldn't talk to our model, now we can give it a piece of text and we can embed it. We can tell the model what it's seeing while it's denoising. So it starts off with random noise, and we tell it, okay, make sure it becomes a picture of a white cat. And it takes that, makes an embedding of it, and gives it to the model while it's denoising. So at every step, we can talk to the model, we can tell it, okay, this is what we want. So in natural language, which is convenient, because that's what we speak. And of course, just a single image isn't going to cut it. We're going to need to give the model a lot of images. For example, we're going to give the same model a new image text pair, for example, picture of a cute dog, and we tell it to retrain it to generate this. Then, for example, a piece of art like the Great Wave of Kanagawa. All right. So based on like a lot of examples, it slowly like learns the link between text and what it should generate. Okay, and that brings us to our ultimate goal. So now we're here, we can just give it a piece of text and our model can diffuse it into the image we want. So it has learned that. All right, but of course, so this is 2 years ago. Since then, we haven't stood still. So some new things that have have been developed with this technology are, for example, inpainting. So inpainting is a technique where you start from an image like this one. You blur out some parts that you don't like. You give it a piece of text describing what you would like, and the model just fills in the blanks. So, for example, here we start out with the little painter, and we give it a piece of text saying a robot, knight, sword, medieval, in a nice piece of text, and it can generate a variation on the image. Then, of course, we can extend images in a coherent way. So we start, for example, we start out from this, and we can make it bigger and even bigger. So this was about a year ago. At Adobe from Photoshop, they also picked up on this, and they also thought it was cool, and they developed their own version, which is called Firefly. And so if you start with this tiny little image of a girl standing in nature, it can generate, it can completely extend it beyond the edges. So that's really going to change the way people use things like, so this is integrated in Photoshop actually already. So yeah, curious to see how that will change the world. Another concept is called Dream Booth. So maybe currently, yeah, you can generate a dog, but it's not your dog. It's a bit annoying. You can't customize it to your own custom thing. So that's why they came up with Dream Booth, and it's actually a way to embed your own images. So you start with the vanilla diffusion model. You give it some extra images. So for example, let's say this is my dog. And then we can tell the model, okay, from now on, if I say dog, use this dog, and it can generate this dog in several styles, which I think is very cool. Then, yeah, okay. So maybe that's one thing I'm trying to hide a bit, but actually we don't have a lot of control over the output of this model. So we can give it a piece of text, and it's a lot of trial and error. So you give it a piece of text, you see the results, you do it again. Takes 30 seconds each time. So people got a bit annoyed with that. And then they came up with ControlNet, which is a way, as the name implies, to give us more control. For example, one way to steer the model is actually to give it the outline of the thing it should follow. So we start off with this image, could be anything. We then also give it these lines and tell it, like, be sure to follow those lines. And it can generate like it can be a very truthful variation of that initial image. Same thing, but with depth, which can follow the depth profile. Here we have the robot made of ice. Or the normal map, which follows more like the shape of the thing we're trying to create a variation of, which looks like this. And yeah, one very recent development is actually a functional QR code. But diffused. So a colleague showed me these. It's very cool. All right. Then. Actually goes to the website that creates a QR code. But you can scan it if you want. I'll just take a work. I tried. All right. Then. Continue. So we have this text and these images. So now we can find out where math meets poetry, namely in prompt engineering, which is a word you might have heard in the context of ChatGPT already, but it's actually also very prevalent for diffusion models because it also uses language. So it's very important to remember the model that we trained, it only knows what it has seen during training, which is something people tend to forget. It doesn't really have a general understanding of the world. It only knows what we have given it. And of course, the more data we give it, the better the understanding becomes. So we took the biggest public data set we have, namely the internet, and we trained a model on that. So now the model has all of that knowledge, which is why it works very well. But that data set itself, if we look a bit closer, where does it come from? So where do we find those text and image pairs that we need? Because we need an image and a piece of text that describes it. How do we get that? Well, actually from images and their alt text. So who knows what an alt text is? Some hands, yeah. Oh, it's a lot of hands actually. All right, so sorry, should stop breathing. So alt texts are actually pieces of text that are integrated in an image for things like blind people actually. So screen readers will read out the piece of text aloud, or for search engines. So Google can't see your image; it can only read the alt text. So it's very important for a lot of businesses to make those alt texts good. Maybe a quick example. So here we have an image I found on Wikipedia. So it's a logo for Wired. Actually, when you go and look in the HTML, so in the code of the web page, this is what it says. So the logo for Wired, the text Wired is seen on a black and white checkered pattern with the color alternating for each letter. Each letter is colored in the inverse to its background color. So that's a very, very specific description, which I would never have thought to be there. But actually, for a lot of images on the internet, you can find this text. So these are actually, so the data set we have for these models actually consists of millions of images from the internet and those types of text. And actually, the fact that it's based on these alt texts gives rise to prompt engineering. So what is prompt engineering? It's just modifying the piece of text that we give the model to improve the quality of the output. And actually, what we're doing in a way is reverse engineering the alt text. But to show that a bit clearer, so for example, we have this from DALL-E. We have here an image. The prompt is a drawing of a dog wearing a party hat. So it's all right. It's passable. But what if we add trending on ArtStation? And we get this, which is a lot better. It's like a lot better. So that's a bit weird. Where does that come from? Well, actually, it can be explained by the alt text. What?
It's a deer, it's not a dog.
It's a dog. No, maybe a bit like this. Okay, let's kind of get time. Passable as a dog. All right, so that's very strange until you realize that ArtStation is actually a website that collects artworks. So people upload their own creations on a website called ArtStation. And when an image is uploaded to ArtStation and it becomes trending, the alt text gets altered to include trending on ArtStation. So all the images that the model has ever seen, including the text trending on ArtStation, were very good images. In consequence, trending on ArtStation becomes like a synonym with beautiful, with artistic, with a good image. So that's how the model reasons about the world, which I think is very cool. And then a small side note. So this it's more of a general reflection on these large language models, because this in fact also uses transformers. It's actually that we see there is a bit of a shift in paradigm towards this data set. So before we used to start from scratch and we collected, curated a good data set, whereas now, for example, for Stable Diffusion and for DALL-E, we actually start from the entire internet and we filter it down. We throw out all the trash, which is something that's becoming more and more important, which is why ML6 actually is focusing on creating a framework which allows you to filter these huge data sets to fine-tune foundational models, which is called Fondant. So definitely go check that out. So prompt engineering is actually the exercise of thinking, what could have been the alt text for the image I now want to see? How would it have been described on the internet? Then for some tips and tricks, because a lot of people have already looked into this, of course. First, maybe let's start with the anatomy of a prompt, like how does the average prompt look like? Here we have a close-up black and white studio photographic portrait of something, dramatic backlighting, 1973 photo from Life magazine, which is a very specific description. But actually specific is good, because remember, the alt texts images that have a very specific alt text are usually good images, because if you care enough to put 1973 photo from Life magazine in your alt text, then it's probably a photo you care about. So it's probably quite high quality. All right, so let's take a closer look. So we have a close-up. So it's like the camera technique that's being used, black and white, it's like modality. Studio photographic portrait. It's also, again, like a lot of terminology of photography, dramatic backlighting, and then something very specific, like 1973 photo from Life magazine. So remember, things you're going to need to do it yourself after this. So, things to include are, for example, the medium you use. Is it a charcoal drawing? Is it an oil painting? The camera, the lens, setting, style, artist, the general vibe of the image. It's all very important. And then we actually get this, by the way. So it's a very nice dog, and it actually fits the description really well. Then some other hacks are actually to include the film, the movie of which you want to mimic the style. So, for example, Sin City, analog photograph of a dog wearing a party hat, movie still from Sin City. It looks very much like the movie. Some other tips are like the camera settings and the lenses. So if you really include the model of your lens, the shutter speed, things like that, the pictures will be 10 times better. Even the illustration style, the medium you use, the program you used to render it. So you have these rendering engines for a lot of models. So all those things really contribute to the final quality of the thing you end up with. All right, so now it's your turn. We're gonna make something all together. It's a collaborative canvas. So think things like Oikonomou's boss, like very intricate paintings, or things like Where's Waldo, or a zoo. So we're gonna try to make something like that, something very elaborate with a lot of parts to it. And the assignment I'm gonna give you is futuristic Amsterdam. It's very far-fetched. So think things like cyberpunk, lasers, neon lights, canals, robots. Go crazy. And the way it works is, here's a QR code. You can scan it. It's gonna be on the screen for after this as well, so you don't need to scan it right now. It's gonna lead you to a form. It's gonna lead you to a form where you can enter a prompt. So I encourage you to think about it for a little bit, what you would want to add. And then I'm gonna show our collaborative creation here on screen. Does it work? Should work. So you have all the time in the world to fill it in, by the way. And then I'm gonna show the thing that we're creating together here on screen while it's being generated. And on that note, I'm gonna thank you all for listening. Any questions? Yes.
I think that like image generation is looking pretty good. I mean, of course, fingers and stuff, but like video is looking a bit more, like the older days of the image generation where it looked like kind of nightmarish. And I'm wondering what you think is like the path that we need to get video generation to make like coherent, like real videos based on prompts.
I think video generation it's a much harder problem because it's because you really need the coherence between frames, which we haven't really figured out how to nail. Because you have some attempts at generating video, but either they're very low quality or they're not very consistent. To solve that, I think we would need, that's my own opinion, it's not very researched, but I think we would really need to find a way, a very compressed way to represent the coherence between images such a way that we can easily generate it. I think, for example, the compression algorithms that we already use attempt that, but not very semantically, I think. But overall, definitely not my research area.
see it as like extending what we're doing with images already, or would you say like to start over from scratch, it's like videos being like source data that we train on?
I think I think it's a different problem, and it would require a different approach.
When I train a model on, let's say, 64 pixels, and then I start generating images on 16 pixels, what happens to the dimensions when I like say, where's the cat? Does it fall away, or how does that work?
So generating on smaller images actually doesn't. So the model will only output the output size that it has been trained on. Actually, when you go more in depth into the models, then they can scale up your results, but in general, you need to stick to the sizes that I was trained on. So a few ways around that, actually, what, for example, DALL-E and Midjourney can do, they can generate images of different aspect ratios, but they're actually applying the same model, but just on multiple frames, let's say, which leads to something very funny when you, for example, ask generate a single cat. The image, the model can only see the size that it has been trained on, so it can then generate two cats. But that's the whole tangent. Sorry.
Super good presentation. So when I've been generating especially in university, I think lawsuits, and it's been artists have been really angry. But now I think when I see how they train, it's essentially because they're learning to generate the image they were trained on. That makes sense. But so is the case with various model encoders, like original, latent, original. So why was that not that big of an issue? Is it just because these got famous?
I think so, yeah, because indeed variational autoencoders do the same or learn the same information, essentially. I think it is because these are bigger and maybe also just a lot better at it. So with variational autoencoders, you got results. If you asked it for a bear with a hat, you got a bear with a hat, but it wasn't very nice bear with a hat. Now you got like a stellar bear with a hat. Any other questions? Yes.
So we just so the next word is only predict the next word, right?
Yeah.
It's just same in the future.
Actually, variational autoencoder. So the other model that we mentioned that does that. So that actually predicts the next patch in the image. This one doesn't work like that. No.
It's like all picture one.
Not really, but it's slightly more involved. So it'll learn like some very fundamental representation of the image, and will learn to scale it up until we reach something we can see, but it'll be a lot more math.
What was the image to image word in this case? And you briefly mentioned where you can pass a dog image and it's going to use a specific dog. How does this, is it like trained differently, or is it just a trick with how you embed the
Actually, if you go back to the part where the clip embeddings were added to the model, the clip embeddings are actually you can interchange between text and images there. So once you could take an image, get its clip embedding, which represents its meaning in a sense in a mathematical way, and then you can pass that to the model as well instead of text. So that's how image to image can work, like creating variations in the same style of an image, for example. Any other questions? Otherwise, I would suggest this.
I'm saying correctly that when you have text and image to clip, so you're embedding it directly by a single one, so that you pass text to one model.
Not by itself. So actually what I was trained for was to assess how close a piece of text is to an image. But yeah.
But it's one single transformer.
It's one model, yeah, it's one model. Yeah, it's not several.